Hello, good morning. Right. So, sorry, yesterday I did not take the class. Today onwards, I continuously have to take the class. Don't worry. Now, mathematical methods of physics completely finished in our app. Right. I given the questions up to the green functions. I given the questions. Now, I should make the questions from the partial differential equations and numerical methods and tensors and group theory. Whatever the old questions are there in the CSR, how the pattern will come. So, those questions I will give to you in this month, no problem. Right. So, we started the classical mechanics maybe whole year, 2025 whole year I have to teach the entire physics portion to you. Don't worry, each and every topic I will cover according to your CSIR syllabus, whether it may be core and advanced, don't worry. Clear? Now we will see the next topic of in the previous class we discussed about the introduction of the special theory of relativity. First, Galileo introduced this relativity, basic principles of relativity. The latter Newton supported that Galilean, so that's why Galilean transformations we also call it as a Newtonian transformations also. After some time, so many people came, but Galilean transformations did not obey the Maxwell equations. To confirm the Maxwell equations, Galilean transformations and Newtonian transformations only obeys the mechanical principle, not obeys the which principle it is. So, those things are there, electromagnetic principles are not obeyed. That is why we have to take which one we have to take, we have to consider the one more important transformations. Those transformations is the Lorentz transformations came. But even though meanwhile a Michelson-Morley experiment is there, Michelson-Morley he gave one theory in the midst of the ether medium, but velocity is changing, a negative result came. So, that is why entire Michelson-Morley experiment is a failure experiment, but it give the success theory. So, that conclusions it will give the towards special theory of relativity postulates. Clear? Now, the today is a very important class. What is that class? Is the special theory of relativity. What is the special theory of relativity? Once you have to see in a special theory of relativity, who introduced the special theory of relativity? Einstein 1905 he introduced a special theory of relativity, right. In 1905 Albert Einstein introduced the special theory of relativity. Already I told, if you have to keep any theory, we have to follow the procedure. Which procedure? We have to keep some assumptions. Those assumptions we call it as a hypothetical ideas. Those hypothetical ideas we also call it as a postulates. So, two fundamental postulates he kept. Based on these two fundamental postulates, he enhanced the theory. That theory is the special theory of relativity. Clear? So, what is that? Once we will see. Now, you have to see Albert Einstein postulated two important conclusions. These are known as postulates of special theory of relativity. This is very important. In a competitive examination, they will give the theoretical bits. How many postulates of special theory of relativity? Two number of postulates of special theory of relativity is there. When he invented 1905, he invented, who invented? Albert Einstein invented the postulates of special theory of relativity. So, what are those postulates? Number one postulate is the principle of relativity or the principle of equivalence. What is that first postulate? The principle of relativity. The principle of relativity we also call it as this one, the principle of equivalence. The principle of relativity or the principle of equivalence. What is that principle of relativity or the principle of equivalence statement? Once you have to see, the law of physics have the same form in all inertial frame of reference. The law of physics, you have to take any law of the physics, the law of physics have the same form in all inertial frames Therefore, no preferred inertial system exists. So, what he tell? No preferred inertial system exists, he told. This is very, very important. The law of equivalence told there is no preferred inertial system exists. There is no preferred inertial system exists. Otherwise, the law of physics have the same form in all inertial frame of reference. One more variety of the definition is all the inertial frames are equivalent in their physical properties. In their physical properties matlab, in their physical properties means there is a law of physics only. The law of physics only. All inertial frames are equivalent. This one we call it as a law of physics only. All physical properties means the law of physics only. Clear? So, two varieties of the statements are given. What is the Einstein first postulate? The Einstein first postulate we also call it as the principle of the relativity or the principle of equivalence. The principle of relativity or the principle of equivalence. What is the principle of relativity? Once you have to see, the law of physics have the same form in all inertial frame of reference, because no preferred inertial frames exist. No preferred inertial frames exist. What is that? Once again you have to see the statement. The law of physics have the same form in all inertial frame of reference. The law of physics have the same form in all inertial frame of reference. Therefore, no preferred inertial frames exist. No preferred inertial frames exist, or otherwise all inertial frames are equivalent. All inertial frames are equivalent in their physical properties. Reverse also you have to take. Say first statement is the law of physics have the same form in all inertial frame of reference, or no preferred inertial frame exist. Otherwise, the inertial frames are equivalent in their physical properties. This is statement we call it as the first postulate of the special theory of relativity, or the principle of relativity, or the equivalence of the principle of equivalence also. This is the Einstein first postulate or first postulate of special theory of relativity. The second postulate we call it as the constancy of the speed. Constancy of the speed. Constancy of the speed. Constancy of the speed. Speed is a constant. What is that? Once you have to see the speed of the light in free space. The speed of the light in which space? Free space. The speed of the light in free space or vacuum. The speed of the light in free space or vacuum always a constant, c, and is independent of the speed of the source, and is independent of the speed of the source. Therefore, the observer, the relative motion of the inertial system, whether it may be observer or the relative motion of the inertial system, if you have to take the reference. So, through that reference, the speed of the light in free space, in vacuum or free space, is always constant. The speed of the light in free space or vacuum is always constant, is independent of the speed of the source, is independent of the speed of the source, the observer, the relative motion of their inertial systems. Clear? This statement we call it as a second postulate of the special theory of relativity. Which one it is? Second postulate of the special theory of relativity. Once again you have to see, the speed of light in free space or vacuum is always a constant and is independent of the speed of the source. The observer, the relative motion of the inertial system. This is the second statement of which one? Second statement of whom? The second statement of the Einstein postulate. Based on whom he derived this one? By using the Lorentz only he derived. In 1890, Lorentz given the transformations. So, those who is Lorentz? H. Lorentz is belongs to the Dutch means Netherlands physicist. So, Netherlands physicist, when he invented the Lorentz transformation, 1890 invented the Lorentz transformation. Who invented the Lorentz transformation? Dutch physicist invented the Lorentz transformation. For this, you have to see, here you have to take a two frames. One frame is S frame. You have to take two frames. You have to consider one frame is S frame. Which frame it is? S frame. One frame is S frame. One more frame. This S frame is moving with velocity c. Moving with velocity c. S frame is moving with velocity c. So, therefore, position is equal to c into t we have to write. That position is equal to c into t along the x direction. Right. One more frame is there. That frame is S dash frame. One more frame is there. That frame is S dash frame. This S dash frame is moving with respect to S frame with velocity v. S dash frame is moving with respect to S frame with how much velocity? V velocity is moving. So, therefore, the position of the x dash frame, the position of the x dash is equal to, S dash frame is equal to c into t dash. That position of the S dash frame is equal to c into t dash we have to consider. Clear? So, for constructing the Lorentz transformations, we have to consider the two frames. One frame is the S frame. S frame is where it is S frame? S frame is moving with velocity c, that is the constant velocity. S dash frame is moving along the S frame with how much velocity? V velocity, right? This is x dash is equal to ct, this position, and this one is the position. But you know that, so what you know? According to the Galilean transformation, x dash is equal to x minus vt. This is the Galilean transformation. Here we have to take one gamma. So, gamma in constant I am keeping because the Galilean transformation x dash is equal to gamma into x minus vt I have to take. Clear? So, now x dash you have to substitute. X dash is equal to ct dash, which is equal to gamma into x is equal to ct minus vt. I am writing ct minus vt I have to write. Clear? So, therefore, t dash is equal to gamma into ct is divided by c minus vt is divided by c. I have to write. C get cancel. So, C get cancel. If you have to see C get cancel. Clear? C get cancel, you have to take the C get cancel minus V by T into C get cancel. Therefore, which one we have to write? T dash is equal to we have to take it as a right gamma by. So, which one we have to take here? Once you have to see gamma by C into, if you have to take the common without cancelling, you have to take the common C minus V into T we have to write. Gamma by C into C minus V by T. So, therefore, T dash is equal to gamma into T into C minus V is divided by C. I am writing. This one you have to take it as a equation number 1. From the Galilean transformation, x dash is equal to x minus Vt, but I kept according to the Lorentz transformation, I am multiplying one factor, that factor is gamma, that gamma I have to find out now. T dash is equal to gamma into T C minus V by C, and C is coming. Now, you have to see that which one we have to see. Now, you know the thing. Similarly what you know, x is equal to the inverse transformation of the Lorentz transformation. Similarly, x is equal to gamma into x dash plus Vt, x is equal to gamma into x dash plus Vt, x dash plus Vt dash, x dash plus Vt dash, clear. So, this is the inverse transformation of that Galilean transformation. I am multiplying one factor, but x is equal to, we know what is x is equal to c into t, which is equal to gamma into x dash is equal to c t dash v into t dash, v into t dash is there, v into t dash. So, therefore, you have to take the common t dash, you have to take the common, here c plus v is there, c plus v, which is equal to c t is equal to. So, this is the equation number 2, you have to take the equation number 2, right. Now, equation number 1 you have to substitute in equation number 2. What is our equation number 1? T dash. Equation number 1 substitute in equation number 2. Equation number 1 substitute in equation number 2. Equation number 2. How we have to substitute? Ct is equal to gamma into t dash is equal to, before only we took gamma t c minus v by c. So, t dash is equal to gamma t c minus v is divided by c into c plus v, as it is have to write c plus v, correct. So, now you have to simplify this. How we have to simplify? Once you have to see here, right, c into t is equal to, c into t is equal to gamma into gamma, gamma square, right, gamma into gamma, gamma square. Here you have to see c minus v into c plus v is equal to c square minus v square is divided by c is there, c square minus v square is divided by c. So, therefore, what we have to take, t is equal to, t you have to bring it into this side, gamma square into c square minus v square is divided by c square is there. Now, you write t is equal to, which one we have to write here, gamma square into c square is divided by c square is equal to 1, v square by c square, which one we are writing, v square by c square. So, therefore, gamma square is equal to, what we have to take here, one t also is there, no, here gamma square into t, gamma square into t, gamma square into t. So, this t get cancelled, therefore, gamma square is equal to 1 is divided by 1 minus v square by c square, 1 is divided by 1 minus v square by c square. Therefore, what we have to take here, gamma is equal to 1 by square root of 1 minus v square by c square. This is the factor we discussed. Gamma is equal to, gamma is one factor, gamma is equal to 1 by square root of 1 minus v square by c square. From this, we have to substitute there. How we have to substitute, how we have to get the Lorentz transformations, once you have to see. First, you know what is the equation number 1. According to the equation number 1, t dash is equal to, what you know, t dash is equal to gamma into, t dash is equal to gamma into, from equation number 1 I am writing, from equation number 1, gamma into t into, which one we have to write here, gamma into t, we have to take, so c minus v is divided by c, this is the equation number 1. I have to take this one from the equation number 1, I have to take, since it is the equation number 1 we have to write. But gamma we substituted here, t dash is equal to gamma into, so which one we have to write here, once you have to say, t you have to bring into inside, c into t minus v into t is divided by c, c into t minus v into t is divided by c we have to write. So, t into c minus v into c is divided by t. So, therefore, what we have to take, t dash is equal to gamma into, which one we have to take here, c into t. So, c into t is equal to what we have to write, c by c, t we have to take, minus v by c into t we have to write, v by c into t, v by c into t, right. So, now t dash is equal to, I am rearranging this, how I am rearranging, once you have to see, t minus v by c I have to write the same as it easily you have to write. So, you multiplied with c and you divided with c into t we have to take, clear. So, what we have to write, once you have to see, t dash is equal to gamma into t minus, so v is there. Now, you have to see here, c into t is equal to, what is that, x, v into x is divided by c square. So, v into x is divided by c square. So, therefore, t dash is equal to, this is the equation you have to see, this one you have to take it as a equation number 3, t dash is equal to gamma into t minus vx by c square. Now, you have to see here, x dash is equal to, how we have to write the x dash value, x dash is equal to gamma into x minus vt, x dash is equal to gamma into x minus vt. So, therefore, this is the equation number 4. From this equation number 4 and 3, where gamma is equal to what we found, 1 by square root of 1 minus v square by c square, this is the gamma value. V by c is equal to, we have to take one more factor, that factor we have to keep it as a beta. Here beta is equal to v by c, beta is equal to what we have to write, v by c is the beta value, clear. Now, based on equation number 3 and 4, we have to derive the Lorentz transformation equations. What are the Lorentz transformation equations? Once you have to see, therefore, the Lorentz transformations are, the Lorentz transformations are what we have to write, the Lorentz transformations. Once you have to see, what are the Lorentz transformations equations? The Lorentz transformations equations are, what are those? X dash is equal to, gamma means x minus vt is divided by, x dash is equal to x minus vt is divided by square root of 1 minus v square by c square, this is the gamma value. Y dash is equal to y, z dash is equal to z, t dash is equal to gamma into t minus vx by c square. So, t minus vx by c square, instead of gamma I have to substitute here 1 minus v square by c square, square root of 1 minus v square by c square. So, these equations we call it as a, which equations? These equations are Lorentz transformations equation. These equations are Lorentz transformations equation. In this Lorentz transformation equations, once you have to take, what you have to consider, suppose you consider it, what we have to consider? We consider, what we consider? We consider whenever we have to take S frame is moving with minus v, S frame is moving, you have to consider here S frame is moving, S frame is moving with what velocity? With minus v velocity. S frame is moving with minus v velocity relative to S frame is moving with minus v velocity relative to S dash frame. Relative to which frame? S dash frame along the negative x axis. S dash frame along the negative x axis. along the negative x axis, that's why we have to take minus v along the negative x axis. So therefore these transformations will become Lorentz inverse transformations. Therefore those transformations will become Lorentz inverse transformations. Lorentz inverse transformations. These transformations will become Lorentz inverse transformations. How we have to write the Lorentz inverse transformations? Once you have to see x is equal to gamma x dash plus Vt is divided by square root of 1 minus V square by C square. X is equal to x dash plus Vt square root of 1 minus V square by C square. Y is equal to y dash, z is equal to z dash, t is equal to t dash into, so t is equal to t dash minus, we have to take it as a t dash, so t is equal to t dash, so t is equal to what we have to write here, t dash plus Vx dash is divided by C square, Vx dash divided by C square into square root of 1 minus V square by C square. So these four expressions we call it as which expressions? These are Lorentz inverse transformations. Lorentz inverse transformation equations. Lorentz inverse transformation equations, correct? Lorentz inverse transformation equation. These equations we call it as a Lorentz inverse transformation equations. What are those Lorentz inverse transformation equation? X is equal to x dash plus Vt is divided by square root of 1 minus V square by C square. Y is equal to y dash, z is equal to z dash, t is equal to t dash plus Vx dash is divided by C square 1 minus V square by C square. In the Lorentz inverse transformation, suppose you have to see space coordinate transformations means, so I am observing here, once you have to see x dash is equal to x minus Vt is divided by square root of 1 minus V square by C square. This is the space transformation. This space transformation involves the time. Left hand side what is there? Space. So right hand side what is there? Time. Right hand side time is there. So that's why this space transformation involves the time. So time transformations, once you have to see the time transformation. What is the time transformation? Here you have to observe, here this one we have to take it as a time. So this time transformation, a time transformation involves the space. So that's why these transformations we also call it as Lorentz transformations. We also call it as a space-time transformations also. Space-time transformation. This is very important. So many times your theoretical bits making like this. What is the space-time transformation? This Lorentz transformations we also call it as a space-time transformation. Why? Because space-time transformations, once you have to see the space transformation involves the time and the time transformation involves the space coordinate. Hence, these transformations referred to as space-time transformations. Clear? The space coordinate, so that space transformation involves the time coordinate, time transformation involves the space coordinates. So that's why these transformations we call it as a space-time transformations. Which transformations? These are space-time transformation. This is very important. So these coordinates we call it as a Lorentz transformations. Once you have to see these Lorentz transformations, you have to take here I am giving some note about the Lorentz transformations. What is the note? Once you have to take, What are the low range transformations? Once you have to see the low range transformations are what are the low range transformations? Once you have to take first x dash is equal to x minus vt is divided by square root of 1 minus v square by c square, y dash is equal to y, z dash is equal to z, t dash is equal to t minus vx by c square is divided by square root of 1 minus v square by c square. So, these expressions we also call it as these low range transformations, we also call it as a space time transformations. Low range transformations we also call it as a space time transformation. Why we call it as a space time transformation? Space transformation involves the time coordinate, time transformation involves the space coordinate. That is why these transformations we call it as a space time transformation. Suppose here the first condition, once you have to see v by c is less than 1 or v by c is less than 1 or v is less than c. V is less than c means the velocity of the s dash frame is very small. The velocity of the s dash frame is very small. V by c is less than 1. Therefore, what we have to take? Suppose you have to consider v by c is less than 1. You have to consider as a less than 1 means towards 0. So, therefore, these low range transformations x dash is equal to x minus vt, y dash is equal to y, z dash is equal to z, t dash is equal to t we are getting. So, therefore, under v by c is less than 1, v by c is less than 1, x dash is equal to x minus vt, y dash is equal to y, z dash is equal to z, t dash is equal to t. Since gamma is equal to 1 by square root of 1 minus v square by c square, this v square by c square towards to 0. So, therefore, gamma is equal to 1 by 1, 1 by 1 is equal to gamma is equal to 1. If gamma is equal to 1, then the low range transformation will become what transformation? Galilean transformation. Low range transformations are Galilean transformations. Low range transformations we also call it as a Galilean transformation under the condition of velocity v is less than c. When v is less than c, what will happen? The low range transformation, space time transformations will becomes to the Galilean transformation. If it is greater than, what will happen? Once you have to see. Suppose note 2, you have to see the note 2. So, what is that note 2? You have to take the note 2, the second one. If v by c is greater than 1, if v by c is greater than 1, what you have to take? V is greater than c. If v is greater than c, gamma is equal to 1 by square root of 1 minus v square by c square, 1 minus v square by c square. But if v is greater than c, what we have to write? We have to adjust this one. How we have to adjust? So, you have to take this one minus v square by c square. So, you have to take plus, you have to write. So, now you have to take here minus 1, you have to bring outside. So, what will happen? You have to see root minus 1, the square root of v square by c square minus 1 it will come. So, the v square by c square minus 1. So, the root minus 1 is equal to I. This is the imaginary part it will come. Which part it is come? Imaginary part. But this due to this imaginary part, practically it is impossible
practically it is impossible, practically impossible. So therefore what we have to write, the velocity is greater than c, velocity is greater than c is impossible, velocity is greater than c is impossible, clear, right? So due to this, if velocity is greater than c, the gamma is going to the imaginary part, the gamma, this factor is not going to the imaginary part practically. So that is why what is impossible, the velocity of the particle is not greater than the light velocity, clear, this is very important. So this is the beauty of the special theory of relativity. What is the beauty of the special theory of the relativity? In the universe, every particle under the light velocity only, below the light velocity only, above the light velocity is not possible. So based on this Lorentz transformation, the second note, clear. Now we will see the matrix form of the Lorentz transformation. How we have to write the matrix form of the Lorentz transformation, you have to see. First we have to take the Lorentz transformation, x dash is equal to x minus Vt into gamma, x dash is equal to x minus Vt into gamma. So therefore x dash is equal to gamma into x, gamma into Vt we have to write, gamma into Vt we have to write, clear, x dash is equal to gamma into x, gamma into Vt we have to take. So therefore, but you know one thing, V by C is equal to beta. So therefore V is equal to beta into C also we have to take, V is equal to beta into C, V is equal to, therefore you have to substitute here, what will happen, x dash is equal to gamma into x minus gamma into V, you have to substitute, what is the V value, beta into C into T. So therefore x dash is equal to gamma into x minus gamma into beta, Ct is equal to, already you know, Ct is equal to, that is the position, x gamma into x minus, so what we have to write here, gamma into x, gamma into beta, gamma into beta, Ct is equal to x we have to write, Ct is equal to, which one we have to take it as a, so gamma into beta Ct we have to take. So otherwise you have to consider that one only, you have to consider in terms of the Ct you have to write, right. So this one you only you have to do, gamma into x minus gamma into beta Ct, right. So you have to take it as a x dash is equal to gamma into x minus gamma into beta Ct you have to take, right. This is the equation number 1 you have to consider, this one is you have to consider as equation number 1, right. Now you have to take the second part. What is the second one? T dash is equal to gamma into, so T minus Vx by C square, gamma into T minus Vx by C square, clear, gamma into T by Vx by C square. So therefore I am rearranging this, how I am rearranging, gamma into T minus Vx, so V by C into x by C I am writing, V by C is equal to, which one we have to write here, beta into x I have to write. So therefore T dash is equal to gamma into T minus V by C is equal to beta x by C, clear. So therefore what we, this C you have to take the LCM, C, otherwise you have to multiply it with C all the equation. So C into gamma into Ct minus beta into x, gamma into Ct minus beta into x. So therefore Ct dash is equal to, Ct dash is equal to minus beta into x plus gamma into Ct plus gamma into Ct. This is the equation number 2. So based on these two equations, the first equation once you have to see, what is that equation, x dash is equal to gamma into x, x dash is equal to gamma into x minus gamma beta into Ct, y dash Ct dash is equal to minus beta into x gamma into Ct. Based on these two equations, I have to make it which one I have to make? So, gamma into Ct minus beta into x. So, I have to make into the matrix form. How I have to make the matrix form? Once you have to see here. So, right, how we have to make these two expressions, we have to make into the matrix form. The first expression is x dash is equal to gamma into x, x dash is equal to gamma into x minus gamma beta into Ct, correct. This is the equation number 1. Next equation, Ct dash is equal to which one we have to take it as a beta gamma into x, which one we have to write here? Ct dash is equal to minus beta, minus beta gamma also is there, minus beta gamma into x, right, minus gamma beta into x plus which one we have to write here? Plus gamma into Ct, This is the equation number 2. Now, comparing these two equations, I have to make it as the equation form, x matrix form I have to make. These equations I am making into the matrix form in 2 dimensional. How I have to make the matrix form in 2 dimensional? Once you have to see x dash, left hand side I have to write a x dash Ct dash, Here x dash coordinates you have to take here, right. Here how many is there? X Ct I have to take. So, now x coordinates I am writing x dash is equal to gamma x, next minus gamma beta, Ct coordinate. So, you multiply first row into first column, the same equation number 1 only you have to get it. Next, so Ct dash is equal to x coordinate you have to take here minus gamma beta, Ct coordinate is gamma. So, therefore, this expression we call it as a, this is the equation number 3. This equation number 3 we call it as a Lorentz transformation, matrix form of the Lorentz transformation, matrix form of Lorentz transformation, matrix form of Lorentz transformations. Not only this, so similarly you have to take the matrix form of a Lorentz inverse transformations. How we have to write? Once you have to see the matrix form of, therefore, or similarly the matrix form of Lorentz inverse transformations, the matrix form of Lorentz inverse transformations is, what is the matrix form of the Lorentz inverse transformation? Wherever x dash Ct dash is there, no, so you have to take the other coordinate, you have to take as a your reference. So, you have to write x comma Ct, this is the x and Ct, which is equal to, these minus symbols will become as a plus symbols, gamma into bt, gamma into beta, gamma into which one we have to write here? X dash Ct dash we have to write. So, this is the matrix form of a Lorentz inverse transformation, gamma beta, gamma x dash Ct dash. Clear? So, these are the informations about the Lorentz transformations. Today is enough. Tomorrow we have to take one more important, what is the applications of the Lorentz transformation. These are all relativistic kinematics. According to your syllabus, relativistic kinematics, these all things will come under the relativistic kinematics. So, thank you. So, please do the hard work, you have to practice, then only you able to remember all these things, otherwise it will clumsy in your brain. So, please so take this app and learn your physics knowledge. Thank you so much.